Okay, I want to summarize lesson 5.4. Actually, even a couple of lessons, or the lesson before that. I want to go over all of our new derivatives. I mentioned some memory aids on the lesson, but there's another little saying, I suppose, that you can try to memorize to help you with these derivatives so that you don't have to develop them every single time. And then I want to take a look at one of the last examples example B, where I suggested that you try simplifying first because it's really going to pay off. So first, our 6 new derivative properties that we will want to internalize. Let's talk about some memory aids. The derivative of the sine of x, I would suggest you draw yourself a quick curve. Or this is, if you're going to have one of them memorized, this is the one you want memorized. A sine curve's rate of change is maximum, neutral at a minimum, neutral maximum. That sounds an awful lot like a cosine curve. Derivative of the cosine curve. Draw a sketch of the cosine curve. Your rates of change begin neutral on the y-axis, and then fall to a minimum, and then climb to a neutral value, and then climb to a maximum. That sounds an awful lot like a vertically reflected sine model. Okay. The other thing I pointed out is that any complementary function, any cofunction, will begin with its derivative will begin with a leading negative. So this is the complementary sign. Its derivative will have a leading negative there. Memory aids. The tangent function has a factor of the cosine of x in the denominator. So does the secant of x. Notice that all of the other derivatives have two factors, either two identical factors or two different factors. The derivative of the cosecant of x has a factor of the cosecant of x. Cosecant of x has a factor of the sine of x in its denominator, so does the cotangent of x. It's a cofunction, so it begins with the negative. The derivative of the secant of x has a factor of the secant of x in it. The secant of x has a factor of the cosine of x in the denominator, so does the tangent of x. And the cotangent of x has a factor of the sine of x in the denominator, so does the cosecant of x. There are your two factors there. Now, the other little memory aid that you can use if you're worried about getting these mixed up and you don't want to develop them on the spot is this little saying called ko ni koko. Ko ni ko ko. This was borrowed from Mr. Innes, and it just really seems to work well for students. It doesn't work great for the cosine of x, but it usually works best for the cosecant of x. And then Mr. Innes didn't notice this works on another function. So Koni Coco will just help you get at least one of these derivatives down. And if you get one of these derivatives down, the other ones will probably fall into place. So here's how Koni Coco works. This is a cosecant of x. Its derivative is the negative of the cosecant of x multiplied by the cotangent of x. And if you get Koni Coco down, then that'll probably leave you with whatever is left for the second derivative. I've seen students try to use the c-pasita, but that's just nonsense. It doesn't sound as nice as Koni Coco. I guess the derivative of the secant of x is the positive version of the secant of x multiplied by the tangent of x. That I can't remember if I discovered it or if it was another student, but I know that it was a eureka moment, and everyone in the classroom was just shouting, Koni Coco, Koni Coco, when we noticed that the cotangent of x's derivative is the negative of the cosecant of x multiplied by the cosecant of x. So you just need these cos or coco to be flexible. Sometimes it means cosecant of x, sometimes it means cotangent of x. There's another Koni Ko. It's a little silly, but so is SOHCAHTOA, and SOHCAHTOA worked fine for us. So is SIRCICSIRTIX, and that worked fine too. All right. I don't know about going into first year class shouting out Koni Coco and saying Mr. Hyde taught me this, by the way, but okay. Example B. The derivative in the lesson turned out to be a bit of a mess to try to simplify it. So let's try simplifying our function first. We've seen this happen in the past. Simplifying our function first can help us simplify our derivative. It'll make differentiating a lot easier. It'll make finding roots of the derivative a lot easier. And this is really going to be useful when we start working with exponential functions in a couple of lessons here. So what could I do to simplify this? Maybe I would try writing this as, I don't know, the reciprocal of the secant of x multiplied by 1 plus the tangent of x. Now, the reciprocal of the secant of x is the cosine of x, and the tangent of x is the sine of x over the cosine of x. Notice that I'm using identity skills without being asked to prove an identity. This is why you wanted to practice proving identities, so that it was really to build up your algebra. And now I don't have any, well, I've still got a quotient, but if I distribute through here, I don't think I'll have a quotient anymore. Let me label that as the original function. I'll have plus the sine of x. So instead of going through the mess that we did in the lesson with a quotient rule and derivatives of the tangent of x and the derivative of the secant of x, it took a couple of steps to do it, and I'm not sure it'll always pay off, but I think it was worth trying it, because now all I have to do is find the derivative of the cosine of x plus the sine of x. And the challenge that I'll leave for you, this is not the challenging part. The challenging part is convincing yourself that this expression is actually equivalent to the expression that we came up with um, or that I came up with in the lesson for B. I'm saying it's a challenge. You're really just going to do this simplification, anyways. Now imagine you were asked to find roots. It's going to be a lot easier if your derivative is simplified, and differentiating is usually easier if you simplify first. So look for opportunities to simplify first instead of just charging in and taking the derivative. It'll really pay off in future lessons. It should sound like a familiar piece of advice as well. So good luck with that. Let me know how it goes.